Okay, so this is not on your notes, but it's something we need to talk about real quick, so just kind of stay with me. This is your number families, which you learned at some point along the way in your math history. Just need to refresh your memory on a little bit of this and what they're called. So this is all of the real numbers. Here are your irrational numbers floating around over here. The inside here we have natural numbers. So those are like your counting numbers, 1, 2, 3, 4, 5, whatever. Then the whole numbers are your natural numbers, but it includes 0. Then your integers are your whole numbers, but now you get negative ones. Okay, so your integers are negative and positive and 0 whole numbers. Okay, like no fractions, decimals, whatever. And then you have your rational numbers. So the reason we're talking about this is because we're going to need to refer to our integers today. And instead of... Why not? This particular picture is not in your notes. I'm just showing it to you. So you're right, you don't have it. You freaked me out for nothing. Okay, so integers, because I figured, y'all don't need to print this out. I just need to make sure we know something. Instead of using the word integers in what we're doing, these sets have letters, capital letters that go with them that don't necessarily make sense for what they are. Like integers is Z. Why? I don't know. They just are. But it's not just a Z, and I know that my projector's not that great. So it's like a doubled Z, kind of like that. Oh, that doesn't look good either. But it's kind of like a double line there. So when I draw that, I just want you to know it means integers, basically. Okay, so just FYI. All right, so now your notes should look like this, yes? Okay, good. You're freaking me out there. So really this page was just for you to have the unit circle. Again, it's kind of like a title page, but this is everything you should know, basically. So let's talk about the parent functions. Let's talk about sine. So our parent function for sine, f of x, equals the sine of x. Okay? And we're going to graph it based on what we know. Now, when we graph these, this is just the parent function, but we're going to have to do transformations just like we have on a lot of things. So the way in which we graph this one is going to be the way in which you kind of graph them all. And it's all about cutting things in half and then in half again, because you have 4 quadrants, and so we're basically finding like 4 little parts on each one of these. There are 5 points total, but that's because we're using 0 and 2 pi, which are at the same place, okay? So what is the sine of 0? 0, okay? So that means that this is 0, 0. Notice that your x-axis there's pi's in there because they're your angles in radians. When else between 0 and 2 pi is the sine value 0? At pi. And when else? At 2 pi, okay? So at 0, pi, and 2 pi, that's when sine is 0, right? Because it's right there on the x-axis. Okay, so halfway between 0 and pi is pi halves. What is the sine of pi halves? 1. So I'm going to plot 1. So I could go halfway between 0 and pi halves to get pi fourths. What's the sine of pi fourths? Square root of 2 over 2. Are you comfortable estimating that on the graph? No, me either. So we're not going to. This is fine. So I'm just going to go halfway between pi and 2 pi. That gives me 3 pi halves. What's the sine of 3 pi halves? Negative 1. Okay? So those are the 5 points that get me that one cycle of my sine value. Now, but I need to graph on here from negative 2 pi to 2 pi. So I need to go ahead and I can copy this over here. It's just a repeat, right? My zeros are at 0, negative pi, and negative 2 pi. Between these two would be negative pi halves. What's the sine of negative pi halves? Negative 1, right? Negative pi halves, I'm going clockwise. Then the sine of negative 3 pi halves is positive 1. Okay? And so I'm only having to plot 0 and 1 and getting them in the right spots. The other weird numbers, they all just kind of take care of themselves, because now I can sketch this in, and this is what my sine curve looks like. That's your parent function for sine. Okay, everybody good so far? All right. What is the domain of this sine function? Okay, negative infinity to infinity. What's my range? -1 to 1, do I? Yes. Okay. All right, zeros. Well, how many zeros am I going to have for my sine function? A lot. What's our technical word for a lot? An infinite amount. There's an infinite amount of zeros, right? Because this is going to continue on from -infinity to infinity. And so they happen every how often? Every pi. So there's 0, then there's a pi, 2 pi, there'll be one at 3 pi, 4 pi, 5 pi, and so on and so forth, right? So I can't put an infinite amount here because this isn't asking me how many, this is asking me what are they, okay? So I have to have a way to put them, and I definitely can't list them all, right? So here's what it's going to look like. It's in set notation. It's a set of all x's such that x is equal to, and so since they happen every 1 pi, I'm going to say n times pi, but n can't just be anything. N can't be 1/2 or 1/3. It has to be a whole number, but not only a whole number, it could be a negative number. So then that's when I say where n is an element of the integers. Okay? It's a set of all x's such that x is equal to n times pi, where n is an element of the integers. Now, I don't want you to freak out. You're not going to have to write that over and over or anything like that. At this point, I want you to be able to understand why it's written that way. And if you get something like that, you could probably make sense of it. And even if you don't feel like you could write that yourself from scratch, if you could at least explain it in words, you'd be fine at this point, okay? So it's just kind of exposing you to that notation, which is something that we're going to get into. All right, what's my y-intercept? 0, 0, good, because it's an intercept. Asymptotes, there aren't any. Amplitude, okay, so that's a term that you don't know. You shouldn't know at this point. We'll actually define it in words tomorrow. But your amplitude goes along with your vertical stretch, and that is that's calculated from basically for the parent function. It's from the x-axis to the highest point, so your amplitude is just 1. And then your period, how long does it take for you to go through that one cycle right there? That is 2 pi. Okay, that's for your parent function. Okay, everybody good with all that? All right, so then let's talk transformations. So your transformations will look like this. F of x is equal to a times the sine of b times x minus c plus d. A, B, C, and D, same A, B, C, and D's that we've had for all of the other transformations we've done. Okay, so I will put this little tidbit of knowledge out there for you. When you are doing stuff in Delta Math, and if you look at like their solution, sometimes they use different letters. They're capitalized and they use them for different things. It really doesn't matter. There's some textbooks that use like P and Q and R instead of A, B. But it doesn't matter. It's where it is and what it's affecting that really matters. Okay, so your amplitude, like I said, that's like your vertical stretch. This A is always your vertical stretch. So your amplitude is just the absolute value of A. Because it has to be absolute value because the negative would be that reflection like it always is. Okay? The period is just, that means that's one cycle. And you find that period equals, it's going to be 2 pi divided by the absolute value of B. Your frequency is how many times you complete a cycle within 2 pi. And so that frequency is the absolute value of B. So that means the absolute value of B will equal 2 pi divided by the period. So the period and the frequency are very much related. If you are given a function like this and you're trying to figure out the period to graph it, this is what you would have to do. If you are given a graph and you need to write this, then from the graph you're going to easily be able to figure out the period, and then you would have to do this to get B. So they're the same thing if you notice. It's just like which part are you looking for? Okay, they're related together. So then your horizontal shift for trig is actually called a phase shift, but still your shift left and right, that is C, just like it's always been. Your vertical shift, your up and down, is still that D, just like it's always been. The midline, and again, we will define this in words tomorrow, but up here for the parent function, your midline is the x-axis, so it's the line y equals 0. If I shift this up or down, then the line that goes through these zeros is still the midline. So if I shift this up 5, my vertical shift is 5, but my midline is the line y equals 5. It's like my new x-axis, okay? So whatever the vertical shift is, your midline is just y equals that. So it would just be y equals d. But it's a line, so it's got to be a y equals. What questions do you have at this point? Anything? All right, let's get cosine done. All right, so my parent function, f of x equals cosine of x. So we're going to graph this the same way. What is the cosine of 0? 1. Between 0 and 2 pi, when else is the cosine 1? At 2 pi. Okay. At 2 pi. 0 and 2 pi. It's the only time cosine is 1. All right, so we're going to go halfway between these two to get to pi. What is the cosine of pi? -1. We're going to go halfway between those two to get to pi halves. What's the cosine of pi halves? 0. And then halfway between these two to get to 3 pi halves, what's the sine or cosine of 3 pi halves? 0. Okay. So that gives you that one cycle of cosine. So then if we just repeat it, right, it's pretty much just a reflection over here. And then at negative pi, I'm at -1. And then halfway in between both of those gets me zeros. Then you can sketch in your cosine function. Be careful when you're doing these with the end with your arrows. Like it's not going to shoot up and keep going up straight. You got to think about what's actually happening at that point. It's going to be curving back down. So you need to represent that. Okay. Everybody good so far? All right, so my domain, it's still -infinity to infinity. My range is still -1 to -1. I'm sorry, -1 to 1, duh. My zeros. Okay, I'm going to have an infinite amount of zeros again. They're not happening at 0 and at pi and at 2 pi and 3 pi. It's happening at pi halves, 3 pi halves, and so forth. Is the space between the zeros still a distance of pi? It is, right? So it's still happening every pi, it just doesn't start at 0. So just like I told you, the cosine is like a shift over, it's the same kind of thing with this. So we're going to say this is the set of all x's such that x equals, it's still n times pi, but I have to start here, so I'm going to add pi halves to that. So if I do n times pi and just add pi halves, that'll get me where I need to be, where again, n is an element of the integers. Everybody okay with that and understand what that means and why we have to write it that way? Okay. What's our y-intercept here? 0, 1. Asymptotes, we still don't have any. Amplitude for the parent function is 1, and the period is still 2 pi. Okay. All right, so our transformations, f of x equals a times the cosine of b times x minus c plus d. The only thing that changed was sine to cosine. So amplitude is still absolute value of A. The period, that's still one cycle. And period will equal 2 pi divided by the absolute value of B. The frequency is the absolute value of B. Therefore, the absolute value of B will equal 2 pi divided by the period. Your horizontal shift is still C. Vertical shift is still D. In the midline is just the line y equals D. Any questions at all? All right, so we're going to draw one more little thing. I should have had you done on both of these. So go back to your sine graph real quick. So we're going to have a parent function, right, that I'm going to make you draw this little thing. And you got to trust me on this. You're going to need this to make sure you get all your little points in the right place when we do this. And so for one cycle of sine, it looks like this, okay? And you have 5 points that are important. They're the 3 zeros here, this 1, and this -1. So when we start doing transformations, those are your anchor points, and then we transform those. Okay, those are your 5 important points for sine. For cosine, okay, your cosine function, it starts up here, looks like this. Okay, I didn't even get it even, but it's okay, I'm going to leave it. So we've got the 1s up here, the -1, and then the 2 zeros. Okay, and it's half, half, half. And if you do it that way and you keep up with that every time, you will be able to do this without any problems at all. Okay, if you're stubborn and you don't do those things, then you're going to get confused. Okay, any questions at all? All right.